solve quadratic equations just like we did in the last video, except this time we're going to use square roots to do it. We can use factoring on these, and it will give us the same answers as square roots, but square roots might be a little bit faster way of doing it. Now, before I do x squared minus 25 equals 0 and solve it, I want to review what a square root is. There are some numbers that have factors that match up perfectly. For example, the number 4. If I were to take the square root of 4, that answer is 2, because 2 times 2 is 4. I'll erase this out of the middle so that I can solve my problems here in a little bit. We could have started with 1. The square root of 1 is 1, since 1 squared equals 1. The next perfect square is 9. The square root of 9 equals 3, since 3 squared equals 9. The square root of 16 is 4, since 4 squared equals 16. And I could keep going with this. The perfect squares, there's an endless number of perfect squares, but I wanted to remind you what it meant to take a square root, because we're going to use square roots to help us answer these problems. Okay, so now, like I said a little bit ago, you could factor these, and they should look familiar to you. This was a few videos ago when we factored a difference of squares. X times x, 5 times, whoops, I'm jumping the gun here a little bit. 5 times 5 is what gives us 25. One of them had to be negative, one of them had to be positive. And then if we wanted to, we could set these factors together, set them equal to 0, like we did in our last video where we were solving quadratics. Okay, hopefully you remember this. This one gives us x equals negative 5. This one gives us x equals positive 5. Okay, but I told you that solving these with square roots could be faster. Shorter, faster, sometimes is usually what people want to hear. So I'll show you how to do that. This is the one time when you're solving these quadratics that you don't want it to equal 0. So the first thing that we actually want to get x squared alone. And we want to get x squared alone so that we can take the square root of x squared. So x squared equals 25. The reason I want to take the square root of x squared is so that it becomes just x. X equals 5. Now, a little bit ago when I did this problem, I showed you that there were two answers. One of them was positive 5, one of them was negative 5. So how am I going to get those two answers here? Well, what you have to remember about square roots is that when I take the square root of any number, there is the possibility that it could have been a positive number or it could have been a negative number. For instance, the square root of 4, I said a little bit ago, was 2. Well, it could also be negative 2, since negative 2 squared gives me a 4 as well. So what I need to remember when I'm done solving a quadratic by taking the square root, I just have to remember that I want to include the positive number and the negative number. And that's a quick way to do it. Just put a plus minus sign in front. Some of you have buttons that look like this on your calculator, although what they do is they just put a negative sign in front. But you can write your final answer when the number is the same, but the signs, you want two signs on it. You can put the plus, minus right next to it, one right under the other. Okay, I'm going to get this out of the middle and move on to the next problem. Now, how do I know when I would solve a problem using square roots rather than using a factor box like we did in the last video? Well, the biggest clue for these is that you're not going to have an x term in the middle. Okay, solving using square roots would not work if there was a term that just had an x to the first power or 7x or negative 2x in it. You want to make sure that your problem just has x squared and no other x anywhere. Okay, so in order to do this, just like I did the last time around, I want to get x squared by itself. So the first thing I'm going to do is I'm going to move that 100. And I moved it by adding it. Okay, now I want to get x squared alone, so I'm going to divide by 4. And x squared equals 25 again, and I just did the answers to this. Square root of both sides gives me x equal to plus or minus 5. Okay? This problem, sometimes you'll get problems set up like this right away where it's not equal to 0, but already set up where all you have to do is just jump right in and take square roots. So take the square root of both sides, and what that does is it gets x by itself. And the square root of 36 could be 6, or it could also be negative 6. So the solutions there would be positive 6 or negative 6. Okay, and this one, again, it's already set up exactly the way we want it to. Square root of both sides, square root of x squared is x, and the square root of 121 can be positive 11 or negative 11. And it probably wouldn't hurt for you to get yourself familiarized with maybe the first 13 perfect squares. That way you don't have to jump to your calculators so fast. So, for example, I already did, what was it, 1 through 4, and we've done 5 several times. So the square root of 25 we know is positive or negative 5. The square root of 36 we just did a little bit ago, plus or minus 6. The square root of 49 is the next perfect square. That goes with the 7. 64. Then we're going to have 81. And then we're going to have the square root of 100. The square root of 121, which we just did. The square root of 144. And then the 1 up to the 13th is the square root of 169, which is plus or minus 13. And I have a hard time remembering 14. I think it's the square root of 196, but I often have to check that one myself. One other thing I want to show you here is what happens if we start with a sum of two squares. Let's say we've got x squared plus 4 equals 0. And I wanted to go ahead and get x squared alone. So I subtract 4 from both sides. Now I want to take the square root of both sides so that I can change it from x squared to x. And I ask myself, what do I multiply together, or what do I multiply by itself to get a negative 4? And a lot of my students right here want to say negative 2. Well, is negative 2 times negative 2 negative 4? No, it's not. So it can't be negative 2. Well, then they say, well, it's got to be positive 2 then. Well, if I did positive 2 times positive 2, I get a positive 4, not a negative 4. Well, what if it's one of each? Well, if it's one of each, a negative 2 times a positive 2, that's not a perfect square. A perfect square is when you multiply exactly the same number by itself. So this one has no real solutions. There is no real number that I can square, add 4 to it, and have it equal 0. Because when you square a number, it's going to turn this positive. A positive plus a positive is never going to equal 0.